Welcome to the lecture on confidence intervals for comparing more than two systems. So, in the last lecture we discussed that how to compare the two alternative system configurations, and we discussed the two approaches, and in one of the approach the assumption was that the number of replications were same, whereas in the other one the approach was that even the number of replications are not same, how can we compare and we can say that they are whether same or different. So, they can be said to be different if the intervals do not contain 0. I mean, if the parameter which is for which we compute the interval, that is difference of their performance measures, if finally the interval which we suggest, if that does not contain 0, we can say that they differ, and if they contain 0, we may say that they do not differ. So, in that case there may be cases when you have more than two systems. So, there are many systems and you have to compare, and most likely the cases arise when one of the system can be considered to be the standard one and others are the simulation readings. So, in that case you have to say that which of the readings, which of the replication or which of the values, I mean run values, they are they can be compared to the standard ones and which cannot be. So, in that case, so let us see if you have more than two systems, even that confidence interval approach can be used. But the question is that overall we are saying that we have to have the confidence level of certain percentage. So, suppose we tell that you with 90% confidence you have to say that you have to get the interval which should contain certain quantity. Now, in that we get the 1 minus alpha by 2 level ultimately. Now, in this case what happens now, so when you have 1 minus alpha is that percentage, in that case we find t n minus 1 and 1 minus alpha by 2. Now, in this case what happens that since you have many intervals to be made, suppose you are having k systems. So, if you have k systems and out of the k system the first one is a standard, and then you have to compare every system with the standard one. So, second is to be compared against first. So, mu 2 minus mu 1. Similarly, third is to be compared to first. So, mu 3 minus mu 1, mu 4 minus mu 1. So, ultimately mu k minus mu 1. So, ultimately you have to have the k minus 1 number of intervals. Now, in that case you see that overall you have to have the target level of 1 minus alpha. So, desired level is 1 minus alpha, but when you have to make k minus 1 number of intervals, in that case the individual level in case of individual interval making, that confidence level which you have to maintain will be 1 minus alpha by k minus 1. So, that is basically suggested by the Bonferroni inequality, and it tells it is used to ensure that the overall confidence level is at least 1 minus alpha. So, for that, so this inequality implies that if you want to make some number c of confidence interval statements, then we would make each separate interval at level 1 minus alpha by c. So, if we suppose want to have 90% of confidence, and if we are making suppose 2 more, so or we have 4 more. So, in that case 1 minus alpha by 4. So, alpha basically is 0.1. So, 0.1 by 4. So, that is 0.025. So, in that case every level, every interval has to be constructed at confidence level of 100 minus 2.5, that is 97.5% confidence level should be there for every individual level. Then overall you will have the confidence level of 90%. So, what we see that in that case for every confidence, for every level, we are making it wider, because once we go for the larger confidence level, we are making that wider. So, that is the case, but that is how it is made, and then in that case it is seen that which of those comparisons, so that contain 0. So, that way we can say that it is not differing from the standard, and if that do not contain 0, then we say that it differs from the standards. So, this is how the comparison is made. Now, let us see that if you have the 5 independent replications for inventory policy, and we are getting these values x1j, x2j, x3j, x4j and x5j. So, for these 5 readings, we had seen in the last problem that we have these 2 readings, this was the first and this was the second. So, we checked with the 2 methods, paired T approach and also modified T confidence approach. So, in that basically the first one was the standard and the second one we did. So, we did x1 minus x2, and in that case we had found. So, x2 minus x1 or x1 minus x2 you can do. So, we do that. So, we do x2 minus x1, and then we found the confidence level or confidence level at 90%, and then we found the interval. Now, in this case we have the 5 independent replications, and if we assume that this is basically the standard one. So, we have basically k readings, and if we take the, if we try to compare these readings, these replications output. So, in that case you have basically 4 values. So, C will be, we have to have the 4 intervals, you have to make 4 separate intervals. So, one will be like for mu 2 minus mu 1. So, for this minus this, another will be for mu 3 minus mu 1. So, next will be mu 4 minus mu 1, and then this will be mu 5 minus mu 1. So, like that you will have the values. Now, what will happen? Suppose we are getting the values. So, what we will get here? Here we will get, suppose x2 minus x1, x2j minus x1j. So, it will be 118.21 minus 126.97. So, we will see that this value will come out to be something like 8.76, something like that, hopefully that. So, it will be suppose minus of 8.76. Similarly, this will be 120.22 minus 124.31. So, if we take that, so once we have that table, so we can have this table. So, what we get is, we get in the first one we get x2j minus x1j. Now, x2j minus x1j, so that is basically the parameter for which we have to make the confidence interval. So, once we are doing that, it will be 8.76, and that will be minus. So, it will be minus of 8.76. Similarly, you have the value that is 120.22 minus 124.31. So, it will be minus of 4.09. So, it will be minus of 4.09. Then further you have the 122.45 minus 126.68. So, that will be 4.23, and that is minus. So, it will be minus of 4.23. Then we have 122.68 minus 122.66. So, it will be 0.02, and similarly you will have 119.40 minus 127.23. So, it will be something like 7 127.23 minus 119.40, so 7.83. So, it will be 7.83 minus. So, this is the value which is computed as the, so once we have to compare by taking the difference between their values. So, once we add, so it will be for 12.85, then you have 16 or 17.08, and then it is 24.91, and so 24.89. So, the mean will be 24.89 by 5. So, it will be something like 4.98, and this is minus. So, this value we get as minus of 4.98. Now, how to get the confidence interval? So, we have 5 values, and for that we have to find, suppose we take the so if we take the pair T approach. So, this is known as paired comparison method. So, we are basically comparing with the standard. So, this is a case of comparison with standard. Now, in that case if we use, so what we get is this is the x bar value and then plus minus. So, the interval how you will make, interval will be minus of 4.98 and then plus t n minus 1 minus alpha by 2, and then you will have s square n by n. So, now for these values we can have the calculation of standard deviation or variance. So, once we compute that, so once we have those values, then we will have use here. Now, the most important thing is that how to get these values. So, once we have these values, from here we can find the s square n, and then what we have to do is how to take this. So, anyway this will be 4, but then what will be 1 minus alpha by 2. So, as we have seen that you have k as 5, so you have k as 5. So, you have number of intervals will be 4. So, C will be k minus 1, that is 4. Now, what will happen? This overall confidence level is suppose 90%. So, that is 1 minus alpha. So, in that case your alpha is 0.1, because 1 minus alpha is 0.9. So, alpha is 0.1. Now, in this case this alpha, because we are making C as 4, so this alpha will be nothing but here it will be this by 4. So, ultimately each interval has to be constructed at confidence level one minus alpha by 4, because we have 4 intervals, we are comparing, because we have 5 ultimately systems, that is 5, and we are comparing against one standard. So, we have 4 intervals, and the Bonferroni inequality tells that for maintaining overall a level of confidence, when you have that many intervals making, every interval must be maintained at a higher level of confidence. Now, that higher level of confidence is obtained by dividing this alpha by the number of intervals we are making. So, in this case it will be 1 minus, this is 0.1 by 4. So, it will become 1 minus 0.025, and that becomes 0.975. So, it becomes 97.5% confidence level. this is for individual level. Now, once we use this formula where the variance term will come here, in that now what should be this alpha? So, what should be this 1 minus alpha by 2 values? Now, the thing is that overall we require 97.5%, every individual interval has to be 97.5%. In that case, now the alpha becomes here the value of 0.025. So, what happens? 1 minus alpha by 2 will be basically 1 minus 0.025 upon 2. So, it will be 1 minus 0.0125. So, it will be 98.75%. So, basically what we see that in the earlier case when we had to compare with only one system, in that case when we have to find, we have to have the confidence level of 90%, then we see here this term comes out to be 0.95. Whereas, if we are comparing with, if there is comparison and we are making 4 individual intervals, so that overall confidence level is 90%, then this comes out to be 97.5% confidence level for each interval, and that is why here it will be 98.75. So, you will see from the table T of 4 and 0.9875, and this is how you will calculate the values of that. So, if you compute the values, what you get, you can solve this and you can get certain values, like if you have I and then you have xi prime minus x1 prime, and once you do with pair T approach, you can do with any approach like Welch approach also. So, we can do with pair T and we can also test with the Welch approach also. So, in that case what we see is, for the second system we have seen that this mean is coming out to be minus of 4.98. Now, in this case what is the half length? So, this quantity which we have seen here, what we compute, this becomes the half length that can be computed, and half length is computed to be something 5.45. So, once we have the half length, we can compute the interval. So, this is basically for the second system, means the performance measure is the value of second system, second replication minus the first replication, that is first one was the standard one. Now, this is coming out, this was the mean which we got here. Similarly, in the table for the third one, so once we have got this half length, means what will be the interval? First will be the lower limit will be minus 4.98 minus 5.45. So, it will be minus 10 point and it will be 4.3, and another will be minus 4.98 plus 5.45. So, it will be 0.47. So, this is how the confidence interval is found out. What we see here, that in this confidence interval, the interval which we get, we are getting 0 into it. It starts with minus of 10.43 and it goes to 0.47. So, we have 0 in it. So, it means that it does not differ from the standard. We can say, we can infer that the second system does not differ from the standard. Suppose you go to the third system. In the third system, if you do you will get minus of 1.23. How you get it? You have to get this value, compute, you have to compute this 120 minus 126.97. So, that will be coming something close to 6.20, and that will be minus 6.20 plus 4. So, this will be this minus this. So, plus 5.01 plus again it will be minus of 120. So, it will be 6.07. So, this way you are going to have the x3j minus x1j. So, you will get the 5 values, you are going to get the mean of it, and that value comes out to be minus of 1.23. Now, for all these 5 values you are going to get the variance, and once you get the variance, sample variance, you are going to further use in this formula. Again you are going to have the same thing. So, this value will be same, t of 4 and 0.9875. So, you will have the parameters here from, you can use any value like t4, and then once you go above you will have all these values. So, you can use from here these parameter values. So, that comes out to be, here you get the half length as 7.58. So, what we see, minus 1.23 minus 7.58. So, it will be minus of 8.81, and then if you do plus, it will be minus 1.23 plus 7.58. So, it will be 6.35. So, for again for the fourth system, if it is found to be 6.36, we get 6.08. So, you will have the confidence interval 0.28, and this will be 12.44. And for the fifth system, you will have the mean value as, so difference, mean of the differences, that is 17.15, and this is coming out to be 3.67. So, you will have half length. So, your interval comes 13.48, and you have 20.82. So, what we see that in this case we get these confidence interval values. Now, in this case you see that for these two systems, here these asterisk mark these readings, they do not contain 0. So, we can say that they differ from the standard. So, this is how you compare the more than 2 systems. Now, this was the case when we had to compare, we had one standard replication and we compared it with that. Now, there may be a situation when we have to compare one from everyone, and when every comparison has to be taken into account. Here we have Q2, I mean you have replication 2 minus 1. So, you have mu 2 minus mu 1, mu 3 minus mu 1, mu 4 minus mu 1, and mu 5 minus mu 1. But then we can have the case where we have all pairwise comparison. So, there we have the comparison with the standard, but we can have all pairwise comparison. So, in that case we compare each one with other one, and then we can try to have the confidence interval, and there also we can see after making the interval whether it contains 0 or not, and we can identify that which of the one how they are, they are having the similarity with the standards or so. So, what we have to say in that you have to find the, so to find confidence interval for differences mu I2 minus mu I1 for all I2 and I1. So, in that case you had one standard, every time you had to simply do the difference from second to one, first, third to first, fourth to first and fifth to first. But in this case we are going to have the comparison of everyone with other, but then we are going to see that this one is on the higher side. So, we are going to have the comparison, one is mu 2 minus mu 1, then we are going to have 3 minus 1 and 3 minus 2. Similarly, you are going to have 4 minus 1, 4 minus 2 and 4 minus 3, and then 5 minus 1, 5 minus 2, 5 minus 3 and 5 minus 4. So, this way you have some number of the intervals that is formed. So, what we see is between 1 and k. So, when if we take I1 as less than I2, so in that case what we get is we get k into k minus 1 by 2 intervals. So, we get k into k minus 1 by 2 intervals. So, if you look at this, in that case if you start from the second data you have 1, in the third case you will have 2, in the fourth mu 4 minus mu 1, mu 2, mu 3 or so. So, in that case 3 and then you have 4. So, 1 plus 2 plus 3 plus 4, 1, so it will be 10. So, it will be 5 into 4 by 2. So, that is why when k is 5, there will be total 5 into 4 by 2, that is 10 intervals. Now, in that case again, since we are making 10 intervals and overall you must have a confidence level of 90%. So, again we will use the Born-Ferroni inequality, and in that case the individual interval must be maintained at a confidence level of 1 minus alpha by k into k minus 1 by 2. So, individual confidence interval has to have confidence level of 1 minus alpha by k into k minus 1 by 2. So, this will be the individual confidence level of individual interval. Now, if you see the earlier case, in the earlier case if you look at from here, what we saw that when we had the comparison from the standard, you had to make 4 intervals, and when you had 90% of overall confidence level, in that case the individual confidence interval was to be made using the individual confidence level of 97.5%. So, you made t of n minus 1 and 1 minus alpha by 2. So, this 1 minus alpha by 2 came out to be 0.9875, because your alpha is basically 0.025. So, 1 minus alpha is 97.5%. Now, in this case it will be 1 minus alpha by 10. So, this value becomes 10. So, in that case your individual confidence individual intervals confidence level has to be at 99%. So, what we see is that 1 minus alpha by 10, and alpha was basically 0.1 for 90% confidence level. So, what we get is here we get 1 minus 0.1 by 10. So, that will be 0.99. So, it will be 1 minus 0.01, that is 0.99. So, you have to make 99% confidence level. At 99% confidence level you have to make the confidence interval. For individual, you know, whenever you are making individual for individual class, you are making this at 99% confidence level. So, 1 minus alpha by 2 will be equal to 0.995. So, basically you are going to look into the parameter that is 0.995. So, against the degree of freedom part, you are going towards this value of 0.995 and you are coming here. In this column you have to take that particular value for the T nu alpha. So, if we take its readings, as we see, you will have I1, and then if you do the all pairwise comparison, in that case I2 will be either the second system, third system, fourth system or fifth one. So, in that case you will have I1 coming as, so 1, 2, 3, 4. So, for the second one, when we take the mu 2 minus mu 1, that value, so difference will be basically its mean of the differences of the second replication minus first replication. So, that comes out to be minus 4.98, and then it will be coming plus minus 7.18. So, you can check it that in this time, because the confidence every time you see that this half length is changing, this half length is changing because of the value of alpha changing, because of the number of intervals every time it is changing. So, when we go for third one, because we are getting 2 minus 1, now for the third one we will have two values, third minus 1 and third minus 2. So, it will be minus of 1.23 and plus minus 9.99, and then further we will get third minus second, it will be getting 3.75 plus minus 9.58. So, we can see that in this we are getting 0. So, it will be minus and plus, so it will be containing 0. Now, in this case it will have minus and then it will also be having 0 into it. Here again you will have 0. Now, we go to 4 minus 1 and 4 minus 2. So, 4 minus 1 will be 6.36 plus minus 8.01, and it will be 11.34 plus minus 8.38, and similarly it will be 7.60 plus minus 5.66. So, it is left upon you to as an exercise that how you find it. For fifth one it will be 17.15 plus minus 4.83, then 22.12 plus minus 3.80, 18.38 plus minus 7.73, and 10.78 plus minus 5.85. This is how you get these confidence intervals at basically 99% of confidence level, when because you had the 10 intervals you had to make. So, with that T nu and 1 minus alpha by 2, you had to compare this, and out of that you can see which wherever you get the interval having 0, there can be said to be similar to the standard one, and otherwise if it does not contain 0, then they appear to differ from the standard one. So, this is how you compare the all pairwise comparison. You can practice more and more questions on that, and you will be having the confidence how to find these confidence intervals. You can refer the book of Law and Kelton for such analysis, as well as the book of Banks. Thank you very much.